Hey everybody. So this is our asynchronous review for the test. For some of you it will be on Thursday. For the rest of you it will be on Friday, depending on if you are in my 4th or 6th hour geo classes. On the day of the test on Thursday or Friday, whenever you have my class, you can just go straight to the test. You do not need to go to the Google Meet, but if you would like to, you certainly can. I will have it open. I will be available if people have questions. On Wednesday, I'm in meetings, so I will not be able to have a meet, which is why I'm making this video. So I would like to go through a few of the questions that are on the review assignment. I'll pick and choose. I'll maybe skip some of the questions like number 1 and 2 because those are pretty basic. You've got corresponding angles. You've got all these names in your notes. So you know that 1 and 3 are vertical, 2 and 4 are corresponding, 7 and 3 are alternate interior, and there's a whole bunch of different possibilities for those. Question 2, same idea. If angle 1 is 125, then every single one of these angles would have to be either 125 or supplementary to 125. So let's see, what would that be? 55? So 125, 55, 125, 55, 125, 55, depending if they're vertical, same side, interior, whatever it happens to be. But in a case like this, pretty clearly you've got obtuse angles, acute angles, and as long as those lines are parallel, the obtuse ones are all congruent, the acute ones are all congruent. I'd rather spend some time on things like question number 2, where it says angle 1 is 7x minus 15, and the measure of angle 6 is 15x plus 19. For problems like this one, you got to take a look at those two angles, look at those two expressions and say, are they equal to each other? Well, it doesn't look like it. This one's acute, that one's obtuse. Or are they supplementary? Same side exterior angles are supplementary, so let's go ahead and go with the equation 7x minus 15, one angle, plus 15x plus 19, the other angle, and those two angles have to add up to 180 degrees. And then we just solve that for x. We'll be able to plug that in, get either one of these. I'll go ahead and do that. You can go ahead and do that also. We'll see what we get once we are done with it. Combining like terms, subtracting 4, and then 176 divided by 22 is 8. So then plugging in for each of these, 15 times 8 plus 19. When I plug that in my calculator, I get 139. At this point, we could say that angle 1 we could find by plugging in x equals 8. In fact, I think that's a pretty good idea. And if you didn't want to do that, you could also say that these two angles are supplementary. So 180 minus 139, but either way we get 41 degrees. Whichever way you end up doing that. And then question number 3, I think, is a good one for us to take a look at. If I say, what's the measure of angle Z? If I don't give any other information, some people might say it looks like it'd be 52 because it's corresponding with this. Other people would say it looks like it's 54 because it's corresponding with that, 54 degree. And it depends which lines are parallel. So for example, in part A, it says if you want C to be parallel to D. So if these two are the parallel lines, and I'm trying to figure out what this angle is, well, check this out. If I cover up that other line, that doesn't change anything. C is parallel to D. I've got these two angles. Since these lines are parallel, corresponding angles are congruent. It has nothing to do with line J. C and D are my parallel lines given in the statement. And so I don't know anything about the angles up here, and my angle must be corresponding with the 54. At least the way that I just did it, it was corresponding. In fact, I don't know how else you would do that one. Corresponding angles postulate. And then for part B, it says, now let's let J be parallel to K. So now I care about J and K because they are parallel to each other. And so if I'm looking for angle Z, all of a sudden I don't care about that line. All I care about is my two parallel lines, J and K. And now I look at those two parallel lines and I've got corresponding angles. Angle Z and 52 degrees are corresponding. So if the measure of angle Z is 52, then J and K would be parallel. If it's 54, then C and D would be parallel. But it can't be both at the same time. And I did that with corresponding. But I suppose I could have looked at same side, excuse me, same side interior angles and done 180 minus 128. But not a big deal which one you do. Just make sure that you keep straight which you care about. If J is parallel to K, then I don't care about that other line because I still see J and K, I still see angle Z, and I can still figure that out. Okay. Second page. Oh, we've got a couple of proofs here. Let's see. I'll maybe leave number 7 for you to take a look at because that's filling in more of the blanks. Let's take a look at number 7 and see what we can come up with on number 7. First things first, I'm given that M is parallel to N. So I'll write that down as the given information. That should be pretty automatic. And then I'm trying to prove that 2 and 7 are congruent. Now you're looking at 2 and 7, and you're saying, well, those are alternate interior angles. And yeah, that's what we're trying to prove. This is me trying to prove alternate interior angles are congruent. So if you ask me, how do you know that alternate interior angles are congruent? And I say, well, it's because alternate interior angles are congruent. We're kind of going around in circles. So we're going to use other facts, other properties that we know to arrive at that conclusion. So given that M is parallel to N, we're going to be able to make some kind of a connection over here. And there's a few different ways of doing this. I don't think it's going to take me 5 steps, but we'll see how this goes. I'm going to go with what I do know. I'm going to say that angle 2 and angle 5 are congruent. And I know those two angles are congruent even without the parallel lines. Angle 2 and angle 5 must be congruent because they are vertical angles. The vertical angle theorem, I'm just going to say vertical angles. I'm going to hit focus, see if I can get this to show up a little better. All right, so 2 is the same as 5, and now I can say 5 is the same as 7. Remember, I'm trying to get to 2 and 7 tied together. So 2 is the same as 5. 5 is the same as 7 because they are corresponding angles. The corresponding angle postulate. And I'm almost there. If 2 is the same as 5 and 5 is the same as 7, that means 2 is the same as 7. That's what I'm trying to prove. We know that because of the transitive property. That's it. I guess I don't need that last line. I was trying to show that 2 is congruent to 7. I did it. I'm done. And so that's the idea there. Let's see. I've got a problem similar to number 8 that I'll do in a different spot. In fact, I think number 9 is probably one that we can go ahead and do. I'm looking for all this stuff. I'm going to turn, no, the light was on. I'm just going to look and see which ones I can figure out. I've got parallel sides here. I've got parallel sides there. So if this one's 58, then this one must be 58 also. If this is 58, well, these two angles are a linear pair. So 180 minus 58 to get 122 over on that side. I see this Z shape pretty clearly in between these parallel sides, NM and PR. So if this angle down here is 31, then the angle up here would be 31 also. Similar, it's a backwards Z shape, but the same two lines, a different transversal. I've got 58 degrees for angle SQP, and that's going to be the same for angle SNM, alternate interior angles. And then I think the only one that I'm missing is this big angle up here. And I think I'm going to have to use same side interior angles and say that if this one's 58 down here, Then this great big one must be 122 because same side interior angles are supplementary. And then if this angle is 31 and this whole thing is 122, I'll do 122, take away 31, and that'll leave me with that angle there. So that would be what? 91? 91 and 31 is 122. Yep, looks good. So as I'm filling them in, now I'm going to look at the questions. NQP, I found that was 58. PMN, that one is 31. MNQ, I found that one was 58 also. And so I'm just filling in the blanks here. NMR, that big angle was 122. NQR, that big one is 122 also. And then finally PMR, hey, that was the last angle I found. That one was 91 degrees. Notice that we're not finding any of these angles inside here. We could find them technically, and maybe I'll even refer to this. It's a little bit tougher to see, but I've got that same Z shape showing up here, alternate interior angles, but now I'm looking at NS and MR as my parallel sides. But if this one's 91, then this one would be 91 also. Or those of you who maybe remember some properties of triangles, you might be able to figure it out even without that. Anyway, once that one's 91, then I've got a vertical angle over here. I've got linear pairs to find that these are 89, and this angle out here is 89 also, either by linear pairs or with vertical angles. Anyway, there we go. That's finding all of those. I guess on something like number 10, we can take a look at this. Given that M is parallel to N, well, one of the things we learned a week ago is that if this transversal is perpendicular to one parallel line, then it must be perpendicular to the other one also. And if that's a 90-degree angle, then 5x must be 90. I know that, and so I can use that to figure out what x is. Divide both sides by 5. And what do we get? 90 divided by 5 would be 5 goes into 9 once. 4 left over. 5 goes into 48 times. And so x is 18. And so now this other angle also must be a 90-degree angle because these two have to be supplementary. And so 9y plus 2x must also be equal to 90. And just by itself, I can't do much with it. But since I know that x is 18, I can plug that in. 9y plus 2 times 18 equals 90. And now I can solve that. I'll move my operation up here. Let's see, 9y plus 36 equals 90. I can subtract 36 from both sides to get 9y equals 90 minus 36 would be 54. And then divide both sides by 9 to get y equals 6. Question number 10 is similar to that, but it's a little bit on the more difficult side because I've got x's and y's, and there's nothing I can solve all by themselves. Or is there? Here, we could do this. I wasn't planning on doing this one, but we might as well. Since these two are perpendicular to this transversal, that means that these two are parallel to each other, which means this angle is the same as that one. This one must be 2y. And the reason I did that is because now I've got this relationship. These two angles are supplementary. 3y plus 2y equals 180. And if 5y equals 180, I could just divide both sides by 5 to get y equals 180 divided by 5. That would be 36, I believe. And once I have that, I can say, all right, well, if y is 36, 2 times 36, this angle is 72. 3 times 36, this angle is 108. And 72 plus 108 gives 180, so that's a good sign. And then I've got these alternate exterior angles, x plus y must be 108 also. And if x plus y equals 108, here we go again. I can't solve this by itself, but I already found that y was 36. So let's plug that in there. So 108 minus 36, that must be 72. Is that right? 72 plus 36. Yep, that's 108. So there we go. X is 72, y is 36. And that's how we can approach a problem like that one. One of the ways we can approach a problem like that one. And then here on the last page, this proof's a little bit on the nasty side. We've got, instead of proving things are congruent, we're proving that their sum is 180. And so we're going to use things like the linear pair theorem that says that a linear pair adds up to 180 degrees. So I might say like angle 1 and angle 2 add up to 180, something like they've got here. Measure of angle 1 plus the measure of angle 2 is 180 because of the linear pair theorem. 1 is congruent to 3 because of corresponding angles. And then we're going to use some transitive property later on. But I wouldn't worry about number 11. I'd say spend more time taking a look at the other proof. The other proof is more similar to the one that you're going to see on the test. Also, not to worry about on the test is this one. It's not a big deal at all. It's not a difficult idea, but it just says this is perpendicular. This is not something that we talked about in class, but why not? I'm your teacher. I can talk about stuff like this. If that one is 12, then this one has to be 12 also. We're going to be talking about isosceles triangles in the next chapter and different properties of isosceles triangles and perpendicular. But I'm not too worried about that. Same thing here. These two would have to be the same if that's perpendicular. And so you just set them equal to each other and solve. But yeah, don't worry about numbers 12 and 13. Not a big deal. And 13 looks pretty similar to one that we already did. So I will leave that one for you guys to take a look at. I will post my answer key for this stuff. So hopefully this video was helpful to you. Make sure you're looking at the review that we did on either Monday or Tuesday, depending on which class you're in. The review video for that, I would recommend, if you haven't seen that already, or even if you have seen it, to go back and review that before the test on either Thursday or Friday. As always, if you do have questions, let me know. Shoot me an email, and I can try to help you out. Otherwise, good luck to you on the test, and we'll see you all later. Have a great day.